Welcome back to the Sandpond Saga. Let's get started. When we make something, it's important to make something new, right? So today, let's make a new cellular automata. Cellular automata is where you have cells and you have rules. The rules tell the cells what to do. So let's make a big grid of cells that can be alive or dead. 60 times a second, each cell follows the rules. Each cell takes a look at all the cells around them in a square shape, like this. Let's call this area the less neighbourhood. The cell counts up all the living cells in the neighbourhood to help it decide what to do. If a dead cell counts exactly 3 living cells, it becomes alive. If an alive cell counts exactly 2 or 3 living cells, it survives. Otherwise, it dies. This cellular automata is all about life and death. So let's call it the game of living. It makes some pretty amazing patterns from quite simple rules. Here's a little moving thing I found in it. I call it a slider, and it was fun to make. Let's post it up online to share what we found. Oh dear, bird. It looks like people didn't like your cellular automata very much. Seems like someone's made that one before, called John Conway. Don't worry, bird. Let's make something different. Let's make something new. Forget the grid. Let's just have a line of cells. And each one can be 1 or 0. And instead of a square neighbourhood, let's just look at 2 cells at a time. There are 4 possibilities for what 2 cells could be: 0, 0, 0, 1, 1, 0, or 1, 1. So let's make rules for each of these possibilities. We could say, if we find 0, 0, change it into a 0. If we find 0, 1, change it into a 1. If we find 1, 0, change it into a 1. And if we find 1, 1, change it into a 0. But that's a bit wordy. So let's just combine these zeros and ones together and convert this nerdy number 0110 into a normal number 6. So this is rule 6 in action. To make it look better, let's draw each frame on a new row. We can see how it changes over time. It makes quite a cool pattern. Let's call this a Wilson code. Specifically, Wilson code 6. And we can explore every single Wilson code from 0 to 15. Here they all are. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's post it online. Oh dear, bird. People didn't like this one either. It looks like it's already been done. Don't worry, bird. 3rd time lucky. Let's make something different. Let's make something new. So far, we've just used one neighbourhood at a time. First a square, then a rectangle. This time, let's use lots of different neighbourhood shapes in our rules. Let's use 64 different shapes, numbered from 0 to 63. To get the shape from a number, you convert it into a nerdy number, and then arrange the digits like this. Flip it over, then flip it over, then flip it over. There we go, we have the full neighbourhood shape. Each cell counts up how many ones are in each neighbourhood and adds them all together. But it cares more about some neighbourhoods than others. Some count for double, some count for triple, and some actually decrease the count. If the final count is bigger than 0, the cell becomes 1. If it's less than 0, it becomes 0. Let's call this LNCA, which stands for Lots of Neighbourhoods Cellular Automata. We can randomise how much the cells care about each neighbourhood to create some interesting behaviours. And then we can gradually mutate the rules to gradually change the behaviour to even more interesting things. It's quite fun, so let's post it online. Oh bird, not again. It looks like Slackman's already did this, and they did a much better job too. Don't worry, let's make something different. Let's make something new. So far, every cell has been in one of 2 states, dead or alive, 0 or 1. Why don't we use some more? Let's say that cells can be empty, cable, head, middle, or tail, and it works like this. Cable turns into head if it's touching another head cell. Head turns into middle, always. Middle turns into tail if it's not touching head. Tail turns into cable if it's not touching head. This lets you make some contraptions that look like wires. So let's call it Cable World. You can make some cool things in it, like a battery and a logic door. So let's post it online. Oh bird, don't give up. You can make something new. Every cell can be empty, full, or ant. The ant can face any direction, and it walks forwards, flipping the colour of whatever it walks across. When it walks on an empty cell, it turns 90 degrees clockwise. When it walks on a full cell, it turns 135 degrees anti-clockwise. Let's call it Luke's ant. And it makes some interesting patterns. If you leave it going for a long time, it makes a sort of column shape. So let's post it online. Sorry bird, it's not your day. Come on, one last try. Let's make something new. Cells can be empty or plant, and plants can be any colour. Plants randomly copy themselves into empty spaces, changing the colour of the copy a tiny bit each time. Let's call it red, green, blue gene, because the plant mutates its red, green and blue values. It produces some very colourful patterns, so let's post it online.